Define power. So we know that whenever they say define, we usually talk in terms of the mathematical expression for power. We know that power is how much work that I can do in a given amount of time. So the more work I can do in less time, the more power I'm said to have. So power, we know it is work done per unit time. So you can define it as simply work done per unit time in words. And that's it, that's power. Now, B part says that a car of mass 1700 kilograms moves in a straight line along a slope that is at an angle theta to the horizontal. And you can see that this is the car, it's on moving on a slope that is inclined at some angle theta to the horizontal. It starts its journey from A and goes to B, covering a distance of 25 meters. The car moves at a constant velocity for a distance of 25 meters from point A to point B. Air resistance and friction provide total resistive force of 440 newtons. So air resistance is not negligible in this case. They're saying that combined air resistance and the friction from the road provides a frictional force of about 440 newtons. So that's the total friction that is opposing the direction of motion of the car. For the movement of the car from A to B, state its kinetic change in kinetic energy. So note over here that they said that the car moves at a constant velocity, right? We know that kinetic energy is just half mv squared. The change in kinetic energy would be half m change in v squared. But we know that it is moving at constant velocity throughout this entire journey from A to B. Its velocity does not change. So that means the change in velocity would be 0. And if that's 0, then this product is just 0 as well. So the change in the kinetic energy of the car from A to B is just 0. There is no change in this energy. Next part says that calculate the work done against the total resistive force. So against what force? Resistive force. We know that work done is defined as for a force, that force multiplied by the distance that was moved in the direction of that force, which is sometimes represented with a dot product. And that distance is the distance AB, right? So this would be the work done by this frictional force. This dot product ensures that the frictional force is causing this displacement. So the frictional force is 440 newtons from the statement, and the distance that it covers is 25 meters. So this would be 1.1 into 10 raised to power 4 joules. So that's 1.1 into 10 raised to power 4 joules. Next part, this says that the movement of the car in part B from A to B causes its gravitational potential energy to increase by this much amount. So when it moves, of course, you can see that it's moving upwards, up the slope from point A to point B, this much height. So if it's moving up, it is obviously gaining some potential energy. Now, we want to compute that increase in potential. We have that increase in potential energy. We have to calculate the increase in vertical height of the car for its movement from A to B. So we want to compute that height that it moves upstairs. So we know that the change in gravitational potential energy, I'll just call it GPE, is given as mg times the change in height. Now this change in height is what I want to compute. I know the change in gravitational potential energy given in this statement, 4.8 into 10 raised to power 4 joules, and we know the weight of the car as well because the mass is 1700 kilograms, and you multiply that by 9.81 meters per second squared, and then you have change in h. So you solve this equation for change in height, and doing the math gives you about 2.88 meters. So the change in height, or the height increase in this height, is 2.88 meters. What about the angle theta? So if you look at this, now you know this value h, which is 2.88 meters, and this forms a triangle, something like this, right? And you know this value as well. So this forms a triangle where you know two heights, or distance and height, and you want to compute the angle theta. We know that in this case we can use sine. So this would be sine theta is equal to 2.88 divided by this high distance 25. Now from this you can easily compute theta, which is sine inverse of 2.88 over 25, right? So let's bring that on the next page. And if you do the math, this gives you about theta as 6.62 degrees, right? So 6.62 degrees. Next part says that the engine of the car in part B produces an output power of 1.7 into 10 raised to power 4 watts to move the car along the slope. We want to compute the total time that it takes for the car to move through that distance from A to B. Now we have the output power, and we know that the work done, the total work done, will be the work done that is done against the frictional force and the air resistance that was combined, the total resistive force. And then there is some gain in potential energy because the car is moving up the slope, so it's gaining some height, means gaining potential energy. So you'll add that to this one, and this would be, let's call it delta GPE. Now the work done against the frictional force is what we computed in the previous part as 1.1 into 10 raised to power 4 joules, and the change in potential energy is also what we computed as 4.8 into 10 raised to power 4 joules, and the sum of these two just gives you 5.9 into 10 raised to power 4 joules. So that is the total work done. Now we have the power as this, and we have the total work done. Now remember, from the definition of power, it is just how much work that you can do in a given amount of time. So that's work done per unit time. So the total power requires total work done. Therefore, the total work done, which is 5.9 into 10 raised to power 4 joules divided by T, and this is equal to the total output power of 1.7 into 10 raised to power 4 watts. Now rearrange this equation to get T is equal to 3.47 seconds. So that's the total time, 3.47 seconds.